All right, I have the pleasure of introducing our next speaker, another original gangster from the Spring team who's been with us since about 2006 and is still here. The spiritual leader historically of the Spring Integration Project, and he's had a huge impact on Spring Cloud data flow. A more than occasional amateur guitarist, please welcome to the stage, Mark Fisher.
Good morning. So I'm excited this morning to provide the first public glimpse of Riff. Riff is a project that we've started at Pivotal, an open source project for supporting event-driven functions running on Kubernetes. And in 2018, we'll also be introducing PFS, Pivotal Function Service, which will be built on Riff and will run on PKS. And like PKS, PFS will be part of Pivotal Cloud Foundry. So the name for Riff started actually in a discussion I was having on Slack with David Turansky. And we then threw that name into the hat with several other names we were considering across the team. And overall, the team really liked the idea of a riff as a small unit that can come and go in a piece of music, something that can be discovered, reused, modified, extended, and composed into larger units. And I think it also fits well with the theme from Ansi's presentation yesterday on learning, to explore, iterate, and adapt. And all of that is even more important when you're working at the level of functions. And one other point on the name, everyone knows that a software project's name needs to also be an acronym. I'll spare you the details of some of the acronyms that we retrofitted onto Riff, and I'll just give credit to Thomas Risberg for the insightful moment where he said, you know, Riff is for functions. And we just stopped with that. So what is Riff? Riff provides developers a service for executing functions in response to events. And that's the only quote from the slides I'm going to read directly. So what does that mean? Our goal is to actually support, for developers, to only have to focus on two things when they're building apps with functions: the function itself and the topic of events that should trigger that function. The topic of events could be low-frequency events, where effectively your function is acting as a task, or it could be a stream of events, a continuous flow of data, or even spiky, unpredictable traffic. And to be able to handle those event stream cases for functions, we're building on the experience that we had with Spring Cloud Stream, Spring Cloud Data Flow, and the abstractions that we used in those projects as well. And most of the current Riff team is actually also made up of contributors to those projects. The functions themselves can be polyglot applications. Ultimately, the workload is a container running on Kubernetes, so that provides a lot of flexibility in terms of what we can run. And we'll look at the architecture to see how different languages are supported. I'm going to jump right into a demo with a couple examples. So I'll start with the simplest thing we could think of for Hello World, which is a shell script. Where we'll say hello to whatever argument is passed in. Sorry. And then I'll turn this into a riff function by pointing to that. And those of you who are familiar will notice that the output looked like we built a Docker container. And if you're familiar with Kubernetes, you'll see on the bottom half of the screen, there's now a greeter deployment with 0 replicas. Then we have this is really just a shell script that invokes curl posting onto the gateway for Riff. So I'm going to refer to the topic that I want to send an event to. And this will spin up the greeter function and respond with that result. And so that was the cold start, but once it's running, it stays active and responds immediately. By default, if there's a single instance, it will scale to 0 after 10 seconds of idle activity, but that can also be configured. OK, let's look at one more example, a JavaScript function that does squaring of a number. So we'll just say, do this in one line. This is square.js. And again, we'll do riff create -f. OK, and so that spins up a container with the square function and returns the result. And again, we have the function running until it will time out after 10 seconds. You'll see that the greeter function has timed out, and square will do so in a moment. So now let's go back to the slides and talk a little bit about what just happened. There's more to it than you might think. First of all, we built that Docker container. So we have the developer scope is as small as it can possibly be. We want to be able to support a JavaScript function, a Java util function, a shell script, as you saw, Python, and we'll continue to expand, but those are the languages that we're currently working with. The code is added as a layer on top of a base image, and the base image is the invoker. So this, from a Spring user's perspective, this is really inversion of control. This is the Hollywood principle. Don't call us, we'll call you, but in the world of containers. Also, in Kubernetes, the deployment unit is actually a pod, so you can have multiple containers. And what we do, in addition to the function container, which has your code on top of an invoker base image, we also deploy a sidecar. And the sidecar provides all of the capabilities for binding to the event topics so that even the invoker implementations don't have to worry about those details. Again, from a Spring user's perspective, this is very similar to the proxy pattern that we see throughout the framework, right? You can put as much of the cross-cutting logic as you can into that sidecar. And we only have one implementation of the sidecar, but we have multiple implementations of invokers. The sidecar communicates with the invoker over a number of different options that are up to the invoker implementation, which ones they want to support. So we can communicate via HTTP, like we did in the JavaScript app. In that one, there's a node invoker that's using request or using Express to handle the request. In the shell example, it's redirecting standard I/O and then executing the code that we sent it. And we're also working with gRPC for streaming. OK, so what we've done with Kubernetes is we've actually extended it by defining custom resource definitions. And the custom resources that you register as a user then can be represented in YAML. So basically, those scripts that I was running were posting YAML into Kubernetes. And then we have controllers that are watching for those resources and then acting on their addition and their updates and their deletions. So there's a topic controller that sees every time a topic is created and registers that with the event broker. There's a function controller that watches for functions and manages the scaling. So we saw deploying to 0 initially, and then it scales based on requests, which we'll look at in a few minutes. The HTTP gateway is just a thin bridge. So when I was posting to those endpoints /greeter/square, but those were actually passing directly to event topics with those names as well. So you can decouple the functions from the topics. They don't have to have the same name. So let's go back to the demo for a moment and look at how a couple of these configuration options work. So just to show you the Docker file that was generated for the Square example, it's pretty simple. We're building on that node function invoker base image. And you can see we're in fairly early days here. I'm running on the 002 snapshot. We just add the Square JavaScript as a layer on top of that. And the function invoker knows where to look for that based on the environment variable. So that top layer is very thin. Then we have the YAML. OK, so the YAML is defining the topic and the number of partitions on that topic. And it's also defining the function. And you can see that the function is basically just pointing to the container that we create from that Docker file. But it also has the topic for input. And this is what I want to change just to illustrate that we're dealing with event topics as entry points to functions. And you can have many-to-many relationships. And it's not just an HTTP gateway that's directly connected to those functions. So for example, I can send the output of my square function to the input of my greeter function by changing that. And now when I rerun the request to square, it's going to call the square function and then send that result to the greeter function and prepend hello. So we're creating pipelines here, and this is the part that probably looks very similar to Spring Cloud Dataflow. Other things that you can configure are the number of partitions on the topic. So let's look at that again. If I change the number of partitions to 10, then by default, the square function will scale up to 10 instances. You can specify max replicas in the function YAML if you want to provide a different value that is something less than the number of partitions. Sometimes you only want a single instance of a function. Maybe it's holding some local state. We'll see an example of that shortly. OK, so now when I update that, and I can use, so I was using request, which is actually in front of our gateway, but when you're expecting a response, which would be the end of the pipeline. In this case, I'll use publish, which is just fire and forget, and we'll send to the square function a bunch of messages. OK, and at the bottom, what we're going to see is that square can scale and would ultimately scale up to 10 if there's enough traffic. And it's scaling up to 3 now. If I killed the wrong process, but if I kill that and start this again, sorry, then we'll see that square scales back down. And when it arrives at 1, it waits for the idle timeout, which is 10 seconds by default. In the YAML, if I want that to be longer, I can specify the idle timeout explicitly. OK. So we'll go back to the slides and talk for a minute about the scaling. So the function controller, in addition to watching the Kubernetes API for functions to be created and updated, it's also monitoring the event broker for lag on those topics. And when it sees lag beyond a certain value, it will increase the scale. And we have a scaling algorithm that we're really still working on the algorithm itself, but we focused quite heavily up front on the ability to scale from 0 to 1 differently than 1 to n. So we want to scale up as soon as there's demand. And we also want to be able to scale down to 0, which is very different than just scaling instances, because once you're in that 0 state, you have to be able to manage when to bring the function back up again. So the function controller has that responsibility by watching for lag in Kafka. It's actually watching the various topics that functions are subscribing to and monitoring that. And like I said, we're still working on the algorithm. We're also still deciding what configuration options that we'll ultimately expose to users. But for now, you have the idle timeout and the number of max replicas. OK, so that's probably the longest I've ever gone in a presentation at SpringOne without talking about Java. So we'll get on to that now. This is an example of a function that is written to use reactor. So you'll notice that the input, it's a little bit more complicated than the shell script and the JavaScript. But the input is a flux of strings, okay, which are just going to be words that get split on word boundaries. And it's returning a map of string to integer. So it's going to be counting in windows of 10 seconds. So that window operation is really what's key here. We're able to have the function subscribe to the event stream and actually read that stream and do windowing operations on that. And then the results are sent out and then could be used downstream by something that's persisting that data, which is what we do in the next demo I'll show using Redis. So what you would do is you would take this app and you would package it in a jar, and you would push that into Riff as the top layer of a function controller, or sorry, function container, and your base layer would be the Java function invoker. The Java function invoker is written with Spring Cloud Function and knows how to negotiate with the reactive flux. But you can also use simple Java functions that just take a string, return an int, or something like that. And so Spring Cloud Function handles those responsibilities. And in the case where you're using the Java function with Reactor, we're actually, the communication between the sidecar and the function container is happening via named pipes, since they live together in the same pod. OK, so we have one more demo that I want to show. And let me just walk through this slide for a minute before I go there. So there's a few different components. We have a UI. And the UI is only doing one write operation, which is to post the clicks as counts for these categories you can vote for, which are some of the main themes of the conference. And those will be passed to the HTTP gateway on /votes, which is then mapped to the topic votes. We have two different functions that subscribe to that. The vote counter is a simple JavaScript Redis client function. So it's just writing those values directly into a hash and just constantly incrementing the votes as they come in. And in the UI, those bubbles are displaying the current vote count, the tallies. And that's coming from that Redis key. The vote stream processor is actually a Flux application that looks, a Reactor application, a Reactor function that looks just like the word counter I showed a moment ago, slightly different in how it's windowing. We'll talk about that when we see the demo. And we set that to max replicas 1 because it's doing windowing of the data. And then it sends its results downstream, and those get written to Redis as well. So the UI is actually looking at the values for the vote count and for the vote windows within Redis. And there's one other piece to this, which is not here, but I'll show it when we get into the demo itself. So first I'm going to deploy 3 functions, the two that you saw on the diagram, the vote counter and the vote stream processor, as well as the Redis writer. And the Redis writer is actually sitting downstream from the vote stream processor. So our Java code doesn't have to write to Redis. It just emits the maps. And the Redis writer handles that. The Redis writer is also listening to events that are being published by the function controller itself. Function controller is always publishing events for the number of replicas that exist for any particular function. And so we can visualize that in the UI. Now I deploy the UI onto the same Kubernetes cluster. It's going to connect to Redis and the HTTP gateway. OK, and when I bring it up, you can see we've got these bubbles. And we have this set up in a mode where I can just mouse over it and create a lot of votes. So, and I've been doing this purely randomly, so don't assume that I am actually voting here for one topic over the other. I'll remove the ones that we're not looking at. But you can see in these meters that we're actually visualizing what the function controller is emitting. So we can see how many instances we have of the various functions. And then at the bottom, we see the windows. So I'm moving around, creating some votes. And the single bars are 2-second windows that are being emitted by a Flux operation. And the shaded background is actually a 60-second window that's shifting every 2 seconds. And there's a single Flux function that is emitting both of those values that then get written to Redis. OK, we also have this demo running on GKE. So I'll bring that up. And you can see here, it's the same demo. We're going to be showing this also in the booth. And in terms of running this on Kubernetes, on GKE, as opposed to Minikube, which I've been using for my demo, the only difference is the service type that we're specifying for the UI itself to be behind a load balancer. But otherwise, the entire app runs directly on both. And we've also been running riff on PKS. OK, so that's pretty much it for my demos. I've got one last slide, which is just a plug for a session later today, this afternoon. I'll be co-presenting with Dave Sire. So if you didn't see the update in the agenda, I'm sure I'll get a lot more attendees now that I've got Dave joining me. And we'll be going through a lot of details about Spring Cloud Function, including showing how you can use Spring Cloud Function to write apps that look like this, but can be also deployed on AWS Lambda and Azure Functions and OpenWhisk. And we're going to keep expanding that as Java becomes available on those other platforms. We'll also dive into more detail behind this app here that I just showed, including the reactive flux that I'm using there. And so I hope to see you later this afternoon. Thank you.